Okay, so now we are entering the timeline where we're going to get to the smaller particles in the atom. So up until this point, really people thought that the atom was the smallest building block of the universe, that there weren't particles smaller than that. Remember that Democritus, the name of atom meant not to be cut. Well, it turns out that actually atoms are not the smallest building block. In fact, there are many smaller particles than that. But it wasn't until about 125 years ago that people were on the hunt for what those particles were. And so our next scientist is J.J. Thomson, and his work uh, is from the late 1800s, about the turn of the 20th century, 1900. But he was the first to kind of prove with experimental data. So there were people, 50 years before him that were very interested in smaller particles, but they didn't have experimental evidence to back up their claim. And that's one of the beauties of science, is that you to get your name on something, you have to kind of prove it, okay, and then it has to stand the test of time. So he was the one who said, actually there's stuff smaller than an atom. So he actually did this through a famous experiment, which I do want you to be aware of. It's called the cathode ray tube experiment, and I will link a separate video that will kind of break down this experiment a little bit more. And you can do a lot of learning about it. It actually, his work with cathode ray tubes kind of led to the development of modern television and kind of the input system in the old, like not like LED screen TVs like we have now, but the old like big TVs. They use this technology. So what he did though on a simplified version is he actually he was a glass blower as well, and he kind of made this piece of equipment, which just again it's just kind of cool that these scientists, I mean, like they dreamed up an experiment and then they made the stuff. It's not like you go to the store and buy this glass tube. So he had to make it and devise it. But he had a glass tube that was mostly evacuated, or meaning there was very little particles in there, and in fact, it was really just an inert gas, and an inert gas being something that isn't going to react. And um, so people did know about electricity. They were developing, and they just didn't really know what electricity was made up of, other than it was like a negative charge. But what he did is he hooked up this glass tube to a battery essentially, and he then passed electrical current through it. And what he noticed is that um, it always went from the cathode end to the anode end, so from the negative end of the battery to the positive end of the battery. And then it also would always bend towards a positively charged magnet, or a certain end of a magnet, and then it would repel a negative charge. And people were very aware of, at this point in time, of this statement: opposite charges attract and like charges repel. And in fact, I would bold star highlight that, and I will definitely emphasize this over and over again. But this is a key fundamental understanding of chemistry, is that opposite charges attract and that like charges repel. And so this then, he basically charged up a gas. So in this tube was an inert gas. And when he put a bunch of electricity through it, a beam was produced, and that beam was negatively charged. And so here's kind of his thought process after doing this experiment, and many, many times in lots of different ways with different gases, and hooking up the battery different ways to kind of see if the results were valid. So what he concluded is that if all that was in this tube was an inert gas, meaning it's not going to react with anything, but when you pass electricity through it, that the charges had to have come from that inert gas, from those atoms that were in that tube. And so he then reasoned that a particle smaller than the atom had to exist. So the atom wasn't the smallest thing. And at the time, he called them corpuscles, which today they're known as electrons. The word corpuscles did not get a lot of swag. It wasn't very popular, so to speak, but that was what he called them. And so since the gas was known to be neutral, meaning it did not have a charge, it wasn't ionized, if you've heard those words before, he also reasoned that there must be a positively charged, because people did know, like, if you have a negative, you have to have a positive. And but he could never find him. So he tried and tried and tried, but he just couldn't devise a way to prove that there was a positive charge within the atom. But he did prove that there was a negative charge. So with this information, he then proposed his model. So you need to know his famous experiment, which is the cathode ray tube, and then his model. So with this information, he then changed the model of the atom from Dalton's, which was just the solid sphere, and the same with Democritus, just the solid sphere. And he called it a plum pudding, and that's because he was English, and that's a very common dessert there, although Americans probably wouldn't like it because it's more of a savory dessert, but that's what he was trying to explain it to his friends. So that's why he was like, look, this plum pudding, it's like a cake, but it's got little raisins in it, and the cake is like the positively charged pudding substance, and then the little raisins are the electrons. Or we could think of it more as like a chocolate chip cookie, or like and you want to think of it like a sphere, so a chocolate chip cookie ball, or like cookie dough with the chocolate chips in them. And so he really thought that there was like this positive pudding, and that's why when he charged up the atom, the pudding kind of didn't shoot out, but these little like electrons, which were sprinkled in when charged by a battery, were small enough and could kind of be like kicked out by the electricity, or that energy going in could kind of flick those electrons out. So that's how he kind of envisioned it. This is totally a wrong model of the atom, but it then paved the way for other scientists to test his model and then come up with their own based off of his research and kind of modify it. So again, I will link some of these videos, but I do like to point out that Thomson's model of the atom, it is spherical. So I like this image right here because it shows kind of the three-dimensional shape. Like atoms aren't flat. Like this one makes it look like it's flat. The one thing I don't like about this image right here is that it makes it seem like the pluses are like a particle, but really Dalton really imagined that the pink part of that image, or like the background of this image, was just like one positive charge, and that the electrons were sprinkled in. So again, this is another image of kind of, if you could picture that beam that was created, it was just a beam of these negatively charged electrons. So his work paved the way for our next scientist, and we'll learn about him in the next video. But this gives you J.J. Thomson's contribution to the atomic theory, which was huge because he was the first person to say there's something smaller than the atom. And you need to know his cathode ray tube experiment, and you need to know his plum pudding model of the atom. All right, I'll see you for the next one.